Okay, yeah. During the intros, we did not say who we are. So who is Derek?
Yeah, so I don't have slides because we want to sort of move along really quickly with this because all of you have been in a class with me. I know Michael is one of the few who hasn't met Leah yet, but it's really exciting to have a class of all people who have returned. This is really amazing. We got to jump through all the norm stuff, the Zoom stuff really, really quickly. So I'm really excited to dive into the work this week and really excited to just sort of see how things are shaping up now that people have made data sets, worked on other things. We'll be working on a brand new repo, which I'll talk about a little bit more, but it'll be really exciting. This thing literally came out on Friday, so we'll be working with like the latest material. So it'll be a lot of fun, I think.
Awesome. And yeah, I'm Leah. I am an artist and programmer currently living in Puebla, Mexico. Yeah, I have worked in machine learning art for maybe about 1.5 to 2 years now. Yeah, met Derek through the School for Product Computation alumni network, and this is some stuff I have made. But yeah, StyleGAN2. Okay, moving on to the class content, the meat of our class. What is a GAN? Yeah, there are a lot of different types of networks out there. The networks that most people use to generate images and video will be GANs, which stands for Generative Adversarial Network. What is special about the architecture of a GAN is that it actually is two networks in one. It has a generator network and a discriminator network. And GANs were first proposed in 2014 by this guy named Ian Goodfellow. But basically the whole cool thing about GANs is that they have these two networks inside, and the two networks are trying to fight against each other and sort of I don't know, they're in this game of who's better at this task than the other. So what will happen is the generator, which generates images, will go ahead and generate an image that it proposes as this is a real image. And then the discriminator's job is to try and detect whether the generator is trying to fool it or not with a real image or a fake image that it has gone ahead and generated / forged. And so yeah, the classic analogy is that of a forger and a bank, in which case the forger is the generator, the thing that is making these fake images. And it's the bank's job to try and detect these fake images and to tell whether things are forgeries or actually real dollar bills. And so that would be the discriminator network. So what happens during the course of training is the generator will first propose something that's really, really low fidelity and not really good. And then the discriminator will say that's not a real dollar. And the generator will go ahead and slowly get better and slowly generate more high fidelity forgeries, more and more, as the discriminator is that's not real, that's not real. And the generator will learn in which ways it can sort of fool the discriminator into thinking that these forgeries are actually authentic, until you get things that are very, very high fidelity that, even for many trained eyes are pretty hard to tell whether it's real or generated. And so, yeah, all of these images are generated, and GANs were first proposed in 2014. And back then they were really small and black and white. And over the years, with advances in GPU technology and also more tricks in the training process, we've gotten to a point where it's really hard for people to tell whether an image is generated or not in many cases. Yeah, and with that said, does anybody have any questions so far? No? Okay. I'll let Derek take it away from here.
Great. Leah, while I'm doing this, would you mind grabbing some of our slides from, I realize now that we're talking about this, would you mind grabbing some of the slides about latent spaces and just bringing them into the deck? Awesome. Thank you.
Sure.
Cool. So I'll go ahead and share my screen because I realize this is going to be helpful to see that stuff. One of the problems of having people from all different classes is I forget who's been taught what. So I realized if you've been in the datasets class and only the datasets class, you haven't covered all the StyleGAN stuff. So we probably just forgot it because we're like, oh, people already know this. So bear with us as we like figure this stuff out this week. So for those of you who are a little bit more technical or maybe just more interested in sort of the machine learning side of things, I thought it'd be good to look at some graphs and just sort of understand a little bit of how the actual network works. I tend not to show this as much in our classes because it can get pretty like heady, but just to walk through what you're sort of seeing here. So on the left-hand side is sort of what we would describe as a traditional GAN network. What you're seeing here is that basically there's these layers of a network. And when you pass things through a generator, it starts very, very small. It starts at like 2x2, 4x4. And as it grows through the generator, it gets smarter and smarter and like higher resolution. So what you're actually seeing here is this like sort of layer. And if you're familiar with machine learning, these might sound familiar, but for the most part, like don't worry about what's in here, but just know that each of these blocks generates a higher resolution of an image, right? So we're starting at 4x4, so it's very, very, very tiny, and then it goes to 8x8, then it goes to 16x16, 32, like basic powers of 2, it goes larger and larger. That is like a traditional GAN network. And one of the problems with a traditional GAN network is that once you reach a certain threshold or a certain size, it kind of starts to fall apart. It's sort of like trying to blow something up in Photoshop. Like you can do it a little bit, but like it gets blurrier and blurrier and blurrier the higher you get. The advancement of StyleGAN, and actually the StyleGAN predecessor, which is called ProGAN, is that they figured out the blocks needed to sort of like res it up higher and higher. So prior to StyleGAN, we really didn't have anything that was bigger than 256 by 256. And for artists, that's like a postage stamp, right? You can't print that. That's like so small. So now we're getting up to a place where, you know, we're at 1024 by 1024 for sure, and these networks could go larger. In fact, like we might look at that in week 3 is like how to make this even larger. We run into some issues, but like it's still possible. So basically, we could do higher and higher resolution data sets here. The other, so like that's sort of the first big thing is that now they're able to produce higher resolution images. The second thing that they introduced was what's called a mapping network, and we'll look at this a little bit more when we get into inference as well. The idea of this mapping network, and this is where I wanted Leah to grab those latent space examples if she could, is these StyleGAN network has sort of a concept of a latent space. And a latent space is, and we'll cover this either after break or whenever we get those slides in, the latent space is a large dimensional array of between -1 and 1, and that allows you to sort of like manipulate that. Don't worry about that too much. But basically what StyleGAN does is it adds this mapping network. And this is what they call the style network. And basically what it does, it says, it sort of takes what would be the normal convolutions or just the normal upresing, and it passes them through this mapping network, which is then able to sort of say like, how should this actually be perceived, or how should it actually change over time? And this mapping network allows you to produce like better resolution images. They're more refined in terms of style and that sort of thing. This is a very, very heady concept, and I don't expect everyone to get it immediately, but that's sort of the idea here is they added this style network, and that's why it's called StyleGAN. And that style network allows you to manipulate the style of the images a little bit more. Some folks will get confused because there's style transfer and there's StyleGAN, and they have similar concepts, but they're not the same thing. But just know that this mapping network is a long and strong, is a strong part of how StyleGAN is able to generate as good of images as it can. Now, the other thing, and we'll look at an example of this when we get to inspiration, this is actually StyleGAN1. And StyleGAN1 had these blocks called ADA in. And the idea here was like this was somehow producing that good resolution image. What we actually found out in the end was that like that's not really true. These ADA in blocks end up introducing some weird watermarking and artifacts. So if you ever see anything in StyleGAN1, I'll try to point out some examples of it if I can find them. But it creates these almost like water droplets on the images. And that was just sort of like a thing of like how you could tell when someone was using StyleGAN1. When they moved to StyleGAN2, they removed a lot of these. Again, I don't expect anyone to understand what this map means. I can barely look at these myself. They removed these ADA in blocks and they put in some other things called like modulated mean and modulated standard deviation, like that sort of thing. Don't worry about these too much, but essentially what they did is the key to this was that they removed a lot of artifacts that were being shown in those StyleGAN models. So we'll have an example in just a minute where like the StyleGAN, we'll compare a video of StyleGAN1 to StyleGAN2 and you'll see a dramatic difference. And this sort of new architecture was able to create this difference. And it was a big, huge leap. So I believe StyleGAN came out in 2018. this new version came out last year, and then the new version that we're going to be working with came out on Friday. So every year we sort of get a new model of this. So I think I can expect like this time next year, we'll have a new version of StyleGAN that will be even better than the previous version. And by even better, I often mean realism. It's worth noting that like the StyleGAN people are really interested in realism. That's why they do faces. That's why they're mostly interested in faces of humans, animals, paintings, whatever. For artists, that realism isn't always what we want, but what I would say is true of these networks is it's easier for you to go less realistic than it is to go more realistic. Or like, because this model is focused on realism, it's easy to find ways to turn off realism rather than try to do the reverse, which is like StyleGAN1 is pretty murky for like non-face things. So even trying to get that to look nice would be hard sometimes. So StyleGAN2 and the StyleGAN2-ADA network, or ADA, I don't even know how it's pronounced. With that network, it'll get even better. And I'll show some examples of that in a minute. I don't really like looking at these crazy like mapping structures like this. What I will generally show people, or at least talk through, is when you run training, and we'll go through this more next week, you will see spit out two things that are like the network of layers. And this is actually like, once you understand what's going on here, it's a little bit easier to read what's going on. So each line item in this map is a layer in the network. And this is actually like the path that these models go through. So this is the discriminator. In the case of the discriminator, it takes in images, right? The idea is that it will see an image and it can figure out whether that image is real or not. That's the important part of a discriminator. That's all the discriminator's job is to do, is to try to take in an image that we provide it when training and decide whether this is real or fake. So the image gets passed in. It's important to look at the output shape. So in this case, this training was on a 1024 by 1024 image with 3 channels. So that's RGB. If you see a 1 here, that means it was a black and white image. If you see a 4 here, that means it was an RGB alpha channel, which sometimes works, sometimes doesn't. If you want to try that, let me know. It's a little tricky sometimes. But this basically means it took in a RGB 1024 by 1024. Labels we'll talk about more in week 3. For now, there are no labels in this data set. So what does it do? It basically takes all of that image in and it compresses it down to a smaller size. So it goes from 1024 to 512 to 256 to 128 to 64 to 32 to 16 to 8 to 4. So these layers in here are a convolution. That's basically almost an edge detector or a texture detector. And then calmed down as a downsampling. So basically it makes it smaller. And then a skip network, we don't need to worry about skip networks. They're like, kind of like a fancy detail of this network, but essentially it's a way to pass things from another layer into this network after you've done convolutions. All that to say, like basically what it does is it compresses down to like this tiny, tiny little image, and then it takes that last image and it tries to figure out whether it's real or fake using all these convolutions. So this output you'll see here is a 1, right? And 1 means true or false. Means yes, it's a fake image, or sorry, no, this is not a real image, or yes, it's a real image. And that's essentially all that this network does, is it takes an image in and tries to figure out if it's true or false. And what you do is when it guesses wrong, so when it says, oh, hey, this is a true image, and our model knows, nope, that's actually a false image, what it does is then it takes that and it changes all of its weights. So the weights are over here. It basically does what's called backpropagation. It will run back through the system and update all of its weights, which is basically like its logic system of like, oh, if I see more red here, I think that's a flower, but now I'm learning it's not, so like now I need to go back and change my weights. That's essentially what a discriminator does. So it like takes in an image, it figures if it's true or false, and then based on that answer, we then update those weights. The generator is a little bit taller. I'm sorry if you can't see this. But essentially, it's pretty similar, except it goes in reverse. So instead of starting at a big image of 1024, it starts with a tiny little noise input. The noise input is actually 512 dimensions. This is that latent space. But that becomes a 4x4 image. So that becomes a 4x4, 2 RGB. So it's literally an image. And then we go to 8x8, 16x16, 32, 64, 128, 256, 512, 1024. Right? So it basically now is scaling up that network. And again, there's lots of layers here. Don't worry about too much about what each of these layers means. But in this case, what happens is, let's say the generator assumes that it is producing a real image, right? Because the generator is just popping out images. When the network, or when the discriminator says, hey, that's a false image, and the model knows it actually is false, then what the generator does, it updates its weights, right? So it says, oh, I need to put more red here in the corner. And then you say, no, that's a fake image. And you say, oh, okay, I guess I have to move the red over to the center or whatever it is, right? So that's essentially the process for these learning. Now, obviously, that's like a simple oversimplification of how it works, but that's really what you're looking at. And so most networks, like most machine learning models, will spit out this network layer somewhere in the training process or in the generator process. So you can always look at that and like kind of like Google some answers and like kind of decipher how things work. But essentially, this is sort of how the network is structured. And the mapping system is actually something that's like not super clear to me how it works. I just know that this G_ mapping is the style mapping. And we'll look at how to utilize that a little bit in inference at the last week class, but just know these are sort of the structures for things. Any questions? Okay, cool. So let's actually take a look at the latent space. I'm gonna refresh here. Oh, there we go. Thank you, Leah. So latent space. So I know some of you have taken classes with me before and we've talked about latent space, so I apologize if this is a repeat, but for those of you who have not, a latent space is essentially if you think about this as a 2D grid, and at any point in this 2D grid is an image, right? So let's imagine at this point is this picture of this person. Now, if you move to a different point in space, you get a different person, right? So this is, if you imagine this just like a 2D grid, if I move from here to here, this person like has a hairnet, this person doesn't, this person has a beard, this person doesn't. So just think about that. Now, positions in space that are closer to each other are closer images, right? So if I'm here and here, I see these two comparisons. If I move to a space that's here, you'll see a very slight difference in hair. Or a very slight difference in maybe facial structure, or eyebrows, or skin tone. So just remember that in the latent space, positions that are close to each other tend to be more similar. Positions that are further away tend to be more different. That's a really important key thing to think about in latent spaces. Now, the other thing to think about, and this is how we do what we call interpolations, is if you start in one spot and you move very, very slowly to the other spot, basically like picking up a point on that line, you will get basically an interpolation or like an animation of a video, right? So we're going from this position to this position, and we're doing it in, let's say, I don't know, 30 frames, and you will see the person change. So that's how we do interpolations. It is using the latent space, and these latent spaces are sort of the key for most GANs. So any image generation GAN that isn't a translation model is usually using some sort of latent space, and that latent space is, as it trains, it's trying to move things into certain locations. So it might have a corner that is all people with short hair. It might have a corner that is all people with beards, or people with brown eyes, blue eyes, green eyes. That would be the idealized version. It's not really how it works, but that's sort of the way that we think about these spaces. And you might often hear people call these feature vectors. We probably won't cover feature vectors too much in this class, but if you watch some of those StyleGAN2 videos, you'll learn a little bit more about that. And the reason we call them feature vectors is because they are features, right? They're beard or hair length or eye color or skin tone color. In other images, it might be a different thing, right? So if it's an abstract image, it might be texture or color in a certain region, that sort of thing. So our latent space determines sort of our feature vectors, and it's a very complicated topic to try to figure out, like, how do I find the exact vector or the exact way to move within this latent space to change the eye color, but nothing else. That is like a holy grail sort of idea of like, if you could do that, then you could almost create a Photoshop that allows you to auto color people's eyes or change the size of people's noses, the sort of holy grail of image generation. So when we show this example, it's all two-dimensional space, right? The reality is that StyleGAN is 512 dimensions. And there's really no way for our brain to think about that. It's just literally like it's like 3 dimensions and then more. So just know that there are 512 dimensions. Again, these dimensions they're not really like, you can't assume anything about this dimension. Like, oh, I found the dimension that changes the beard, or the, beard, no beard, that sort of thing. It's not really what happens. There's a thing called entanglement, which means, vector 12 plus vector 15 plus vector 18 might actually make up the beard. And may even be weighted differently. Like, vector 12 carries more of the weight for beard, and other ones control other parts of your face or other parts that sort of make it look like a beard. So latent spaces, we'll talk a little bit more when we get into inference because we'll start to see how to change them. There's also like, because of that mapping network, that W network or the style network, there is a latent space that is the like basic model latent space, and there's that mapping network. And what you end up doing is you end up like sort of like combining them, and you understand how to map from one network to the other. And the W network, that style network, is actually a cleaner, less entangled space. And that's what we want to really work with when we can. But there's always challenges there. So like that sort of that gives you a sense of how the StyleGAN networks work, is like they're sort of like kind of have their own game going on where there's the latent network and there's a style network, and they kind of work together, but they kind of don't. And it's like there's some challenges there. So we'll look at this a little bit more, especially when we get to inference, but just so you're aware, like starting to wrap your head around how the StyleGAN network thinks, because the more you understand how it thinks, the more you'll be able to sort of understand where training goes wrong, or especially when inference, like when you're actually generating images and video, like what to do or how to manipulate things. Cool. So we're just at time, so this is great. I think we're going to be on time with class today. So let's take a 5-minute break. So that is 48 after. So why don't we come back in 5 minutes, go grab water, stand up, stretch for a little bit, and we'll come back and we'll look at some cool examples of work people have made. Cool. All right, see you in 5 minutes. Any other questions? Okay. It also might make a little bit more sense once you start training and you sort of can see things updated, that sort of thing. If anyone's interested, there are some really good videos from, oh man, I never remember the order. It's like brown 3, blue 8, or so. I'm totally blanking on what the name is. But there's a really good series
like
that he does in, what is it?
3 brown, 1 blue. It's
3
because
brown.
like he's got a quarter of eye that's pretty little brown.
Okay. Yes, perfect. Okay. I'll post some links to those videos. If you're really interested in just sort of seeing the basics of how a machine learning model trains, like he's got like maybe like I think it's like 30 minutes or 40 minutes of like a really great example of how to like visualized model of how it all works. So I think that'd be pretty cool. I'm actually going to make a note to myself and Leah to find those ML videos. Cool. Yeah, okay, great. So we can get started again. So Leah, maybe you can just like tag team and speak up about some of these inspiration projects. Cool.
Yep.
So I know that one of the things that people are really excited about is just like seeing other people's work and trying to understand how to work through things themselves. So I can show just sort of like a bunch of examples of some of it's student work, some of it's work from other people that, you know, Leah and I are really inspired by. All right, so first off, as promised, here's an example of sort of the StyleGAN1 versus StyleGAN2. So on the left, StyleGAN1, on the right is StyleGAN2. You can see how much of an improvement it was between these two models, right? Now, I could say that maybe this one's a little undertrained, but I honestly would not blame the training on that. And if you look, I don't know if this video is going to have any watermarks. I can probably find an example of the StyleGAN2 video where they talk about these watermarks and how they go. But you'll see like it's just kind of blobby. It's like there's not really clear, crisp details. Some of that was because of the network. Some of it was just like certain weights and those sort of things that they trained with. But you'll see StyleGAN2 is much, much better just in the way that it works. And so this week we'll be starting on StyleGAN2-ADA, which is again this model that just was released. In fact, it's so early I wasn't able to move over the code to generate latent videos yet. So I just have static images for you. But you'll see like the actual shape and the structure of the images is better. And you can't really tell because this is pretty small, but the textures are also much more realistic. So this has actually only been trained for about a day and a half or 2 days. So, you know, you might not know that that's like a very short period of time, but that is a very short period of time. So already we're seeing huge improvements in this. And I've just started, like I started running this model on Saturday, Friday evening, something like that. So we're about 2 days of training time with this. And I expect to get even better as we train it longer. And we'll talk about that more next week as we look into training on our own servers. But just know that like we're seeing leaps and bounds and improvement every year. The other big thing that was really, really important about this model is specifically designed or architected to work with smaller data sets. So prior to the ADA version, The StyleGAN folks who are like researchers at NVIDIA were basically like, you need a data set of at least 30,000 images. Now, as hobbyists, we were able to find it like, that's not really true. You could go smaller than that. But this technique, what they're doing, which is the actual ADA part of this, which we'll talk about more next week, is really focused on a much smaller data set, so 1,000 images. And if they say it's 1,000 images, what we can get away with is 500, right? So like, you know, this has way more opportunity for us to work at smaller scales, which for many of us is like realistic, right? In that data sets class the last time, we were like, there's no way I can get to 10,000 images, much less 30,000. And now they've sort of brought it down to a place where it really doesn't require that many more images. And we'll talk about the techniques they use to make that possible, but just know that like the whole point of this is that you work with a smaller data set. This data set from the very beginning is about 1,300 images. So you'll see 1,300 images with StyleGAN1 was very bad. 1,300 with StyleGAN2 was much better, and already at StyleGAN3, I keep calling it 3. Other people are calling it 3. It's like a new version of StyleGAN2. But yeah, you can see already, even with a short training period of time, that it's gonna turn out to be really, really good. So really excited to start working on this. I will tell you that it's going to take me a little bit of time to get things up and running for everything. So we'll talk about this more at the end of class as you get stuff installed, but you might have to run a lot of Git pulls to get updated code and that sort of thing. So I'm gonna be working on it over the next week or two. But I sort of made the decision after like playing around with it. I was like, we have to teach this in class because it's like, one, it's perfect timing, and two, it is much improved in many ways. I'll talk about those improvements next week. So really excited to get started on this. But yeah, all the other examples you're going to see here are either StyleGAN1 or StyleGAN2. So if you have not yet made a data set, or you're just interested in playing around with data sets, one thing you can do is use video as a data set. So this is an example of, whoops. This is an example of a video as a data set. So again, it's just sort of water, waves, that sort of thing fed into, this is actually trained on Runway. This is StyleGAN1, I'm almost positive, because I can just tell from the quality of it that it's not that great. So StyleGAN1, but you can see what's really interesting about using videos as a data set is like, it sort of replays the video, but like in an inconsistent sort of manner. It doesn't like reproduce it completely, right? It sort of like understands certain parts of motion, and then it sort of like jumps to other places where there's motion, right? So the wave never really goes from the top and crashes down at the bottom. It sort of like hovers in the middle, and like, this is again where you could play with latent space to try to get it to move from top to bottom, but it would probably do weird things in between.
Kishiyuma is an artist in Japan, and he pretty much like his MO is using video as a data set and training a StyleGAN model or other models on it. So you can see like in the middle, he probably took a video of like someone just like doing this with their hands and then fed it through a StyleGAN network. And yeah, I think the output is really, really cool. And yeah, he is one of the people I'm inspired by. A friend and I interviewed him, and yeah, read an article. There's an article if you want to read it.
Like, do they take an image at a certain rate, like a frame at a certain rate of a specific video? Is that what the input?
Yeah, so there's you can take a video and then split it on maybe like every second or so. One thing you can play with is like how often you're sampling. But yeah, I think if you do, like in the past when I've worked with video before, I've split on every second, and that way it's guaranteed that, you know, the frames are like far enough apart that that you won't get like things that are like almost exactly the same, like a hand and then like it like right next to it. Mm-hmm.
Yeah, I think I usually do every frame per second, or maybe like at most like 6 frames per second. Because again, if you have too much data of the same image, it just sort of like repeats itself, especially if the motion in the video is not fluid. Like if there's a moment where it pauses on something, you really want to make sure you don't get 50 frames of that pause, because it's just going to sort of like over index for that.
Mm-hmm. This was a couple of students I had last summer. They essentially like they took textures that they generated from StyleGAN, which is the colors, and then used that as a texture on top of an animation. And I think like different colors correspond to how extruded a particular like blob is. And so it's kind of like they took a interpolation video from the output of like a StyleGAN network, but then used that in another program as a texture for like determining how extruded this blobby thing was. And so it's like an interpolation video, but like folded around a 3D structure. Mm-hmm.
I feel like, is that from you, Leah, the bells?
Oh, yes, that is.
No, it's fine. It felt like perfectly synced up to this, which is like, you know, I think it might be Arabic tile. I don't know exactly where it's from, but you can sort of see it's like, you know, these beautiful tiles that she was then, Juliet, who was a student in Leah and I's class in January this year. So this is probably still StyleGAN2, I'd imagine. But you can just sort of see like the textures are really interesting, especially as they interpolate. And, you know, I don't think Juliet trained this for too long. It was probably like a couple days. So you still get a little bit of that fuzzy texture as it like isn't fully finished training. But just I think, again, like really interesting applications. Again, here's a data set that you could probably scrape off the internet if you like dug around hard enough. So just some interesting opportunities here to think about, you know, architecture, tile, pattern, like those sort of things are good potential data sets because there's a lot of it. This is Elena's work, who again, I think was a part of our January class. She is very into birding. She was able to explain all of the details of each of these birds and like, this is not actually the right bird and like, you know, that sort of thing. But I just love that she was able to take something that she really appreciates, which is birding, and able to find like a very particular set of birds and then feed it through this network. And what I really love about this is like, as she will tell you, like it sort of like highlights the what's the word, the trend, or like just the way in which people shoot birds, which is they're always perched on a tree and they're always centered, and like it kind of works as a data set for this. But it's really interesting to sort of see the bird get bigger, smaller, different types of trees grow around it, that sort of thing. So it's really interesting. And again, I think it plays on like what I try to highlight with folks, which is like take something you're interested in and like really build on it, because that's where it gets really interesting. Esteban has been in many of our classes. I think many of you have met Esteban before. His sort of StyleGAN du jour are actually using vector images. So he produces a lot of these abstract vector shapes in Illustrator. He then generates like big, huge data sets of them, and then he feeds them through StyleGAN. What I really like about this is you can still see their vectors, but they end up taking on a texture. And that's because StyleGAN is really meant for photography. I always describe it as like it's a zebra finder or like a texture finder. The whole point is that it finds textures. So when you feed it flat vectors, it's still going to like sort of make a little bit of light texture in there. It's just some really interesting stuff. Esteban does a bunch of work. His Instagram account is linked to from here. He's been doing a lot more with audio reactive stuff as well. So definitely recommend checking out his work if you're interested in more vector stuff. We might cover this a little bit in the last week of class, but there's a concept of truncation. Truncation is what I would describe as like the realism of an image. It's actually sort of like a mathematic property of these models, which is truncation is essentially the bound from the most average image possible. So truncation is usually a value between 0 and 1. It can actually go to infinity, but most people stick it between 0 and 1 or 0 and -1. And at 0, which is the image you see, actually maybe this isn't the image you see here. So this, if I back up just a little bit, let's see if this works. So this image here, in the StyleGAN2 FFHQ model, this is what has been described as the most average woman in the StyleGAN model. This is, if you set your truncation value to 0.0 in FFHQ, you will always get this woman. She is like dead center in the middle of every latent vector, essentially. And what you're able to do from there is you can take a vector and you can use truncation on it. And as you get further from that 0 space, this is probably 0 up to like negative or +2 or maybe even higher, you get into weirder and weirder ranges, right? So you can sort of see like, you know, up to a certain point, these images all look fairly realistic. And once you go further and further out, it gets weirder and weirder and creepier and creepier. And this is part of what we use with truncation is we just determine how diverse should our images be. So the inverse of truncation, which is like there's realism, right? So if I set it to 0, I'll always get a very realistic looking person. If I set it to 0.5, I will get like a pretty good range of realistic people. If I set it to 1, I'll start to get some weirdos. That is sort of at the edge of that. The inverse of that is that like diversity changes, right? So at 0.0, you get no diversity. You get the exact same image over and over and over again. At 0.5, you will have more realistic images, but they'll be less diverse. And then at 1.0, you will have slightly less realistic images, but more diversity. So you can utilize these techniques to generate weirder looking images of your data sets or more realistic. And that's sort of how people tend to use truncation. A technique we might look at, or actually I can mention how to do this starting next week, but there's a concept of mixed modeling, which is, and we'll talk about this a lot more next week when we talk about transfer learning, but there's essentially a way for you to take one model that you've trained, start training another model for a very short period of time, and you generate what is sort of like a mix and interpolation of these two. Now there's lots of different ways that people do this now. There's a thing called network blending, which is a different technique, but basically you train something for a very, very short period of time. Clearly I need to turn off the ads on all these things. And then you can sort of like, so this is that flower model that I showed you before, and then also like a thing of like abstract oil paints. So you can sort of see it's picking up both of those, right? You can sort of see the flowers, but they've sort of been like flattened or smushed a little bit. And then you get a little bit more of that paint color texture. So in the way this technique is fairly easy to do, you just train something for a very short period of time, maybe an hour, maybe 2 hours. And then you take the pickle file, which we'll talk about more next week, from there. And then you can use that as sort of your next step. A lot of people, we'll talk about this a little bit more when we get to Runway, but one of the things you can do with the Runway model, because you're training off of FHQ, which is the face model, you get really creepy looking faces for like the first hour or two of your training, because it's sort of picking up the other model on a human face, and it gets really weird. But you can also do it with different models as well. So I'm showing here like flowers and oil paints, but a lot of people will generally show the creepy looking faces because a lot of people transfer learn off FFHQ. Projection, we probably won't get into in this class, but there's a video on how to do it if you're interested. There's a concept of basically trying to find, you basically give the model an image and it tries to find the nearest representation of that image inside the model. So this is Gene Kogan. If you're not familiar with his work, I definitely recommend checking him out. Really amazing machine learning artist. He has not been trained in FFHQ, right? Like there's no face of him in that data set. But what we can do is using some loss functions, we can actually put his face into the model and try to find his nearest neighbor or like the closest version or like the GAN version of Gene. This is GAN Gene here. So this is a thing you might see people do more of. One thing that people love to do is they do it with like really weird things. So this is this person AK on Twitter. I highly recommend following this person if you are not. They list literally every interesting machine learning paper ever, and they also find the GitHub repo and list it. It's really amazing. But this is Mario being projected into the latent space. It gets really, really creepy, obviously around here. And so with a lot of this stuff, it's slowly moving toward the nearest face it can find. And as it gets closer and closer, it takes longer and longer to do, right? So now the mustache is actually coming in. Like, it's pretty amazing. This is like goth Mario, like a lot of eyeliner here. But it's like, because this is going to run for another 30 seconds or something, like it's getting really, really close. And like people are like, how does this work? Or like, what's inherent about the model that this is possible? And I think this is one of the things that's really interesting about StyleGAN models in particular is like, when we talk about training, a lot of times we think about like, oh, it's clearly just like memorizing the images that it already sees, right? And that's not really how training works. Like training works in the sense of like you and I being educated, right? I always describe like some of the training process as like, if you're taught a foreign language, the way to test whether you are good at that language is either to have a conversation or to like maybe translate sentences. But if I ask you to just translate a sentence and the sentence looks good, that's not the same as learning French or like learning a separate language, right? You learn all these other things behind the scenes just to be able to create a sentence. And this is sort of the model saying there's a lot of stuff hidden deep inside these models that don't come out when we actually just sort of say like, hey, generate a real looking image, right? So then this is starting to like show that there's like all these weird little corners of the latent space. And you can find really creepy looking things inside of them. Or, maybe when we get even better models, we can actually just find my face in this model, because we have either more vectors or a better vector representation. So we talked about feature vectors. There's also this concept of like, can you actually manipulate a feature vector, right? So a pretty common thing you'll see a lot of people do is they will find there's a thing in StyleGAN1, or at least maybe in StyleGAN2, people have found it. They've actually sort of found the vector that causes people to smile. And you can then do that projection. You can project an image into it, and then you can make it smile, right? So this is making Mona Lisa smile, which obviously has like a funny connotation to it. But lots of people will do this in different ways. So this is Mario Klingemann, who, if you haven't seen his work, definitely have to see his work. He does lots of amazing things. This is him sort of like playing with that feature vector concept and being able to see people smile. This is Robert Luxemburg. I'm actually, you can just watch this video. The music is kind of annoying to me, so I like muted it. But this is actually audio reactive. And what they're going to do when there starts to be some singing is the mouth is actually going to open and sing along, right? So there's actually it's like a new model that came out a month or two ago called Wave to Lip or something like that. And it basically takes this concept and like blows it out even further. I don't know if, let me see when this starts to sing. There we go. So now it's singing, right? So like as it hears words, it opens its mouth. Now, the concept behind this is actually that he found an audio track that is separated out into layers, right? So he found just the vocal track, bass track, drum track, and each of those tracks controls different things. So the vocal track, as it gets louder or quieter, controls that mouth opening vector. And other sounds like convert, like maybe the truncation or like some other part of the vector space. So this is something you can do. This is sort of like partly StyleGAN, partly like just audio reactive generative art, which is when you have other things that are controlling your model, what can they change in the model? Truncation, vector latents, feature vectors, like all these sort of things. So again, we probably won't cover this in class, but we do have a video on how to do this. It's like a very basic level sort of thing. So if you want to blow this out, you could probably find out how to do that through those notebooks. And as I mentioned, like one of the holy grails of StyleGAN is, or any GAN really, is being able to figure out how to manipulate these vectors in a meaningful way. And one of the tools that people have come up with to do that is this thing called GAN Space. GAN Space is a tool that basically does what's called PCA, which is principal component analysis. It's a very mathematic term to say that it basically compresses these vectors into their major representations. And then they built a GUI that I don't think is really usable. Like this is much nicer than it actually like works. But there are ways to manipulate the sort of vector layers. So what you're seeing here is these component numbers control various things. So there's a component that controls sort of color of a car. There's a thing that maybe controls sort of background of the car or like reflections. And you'll see it's not perfect, right? Because this is again that idea of entanglement, which is like you can be changing a variable that you think is doing one thing, but it's kind of also changing other things. And this is sort of the challenge of GANs, is that there's no way to say like, hey, let's change just the eye color, right? If you change the eye color, you might also change like how much the eye is open or eyebrow color or lighting around the eyes. So it's definitely a challenge. And I think this is one of the fun tools you can play with. We do have a notebook for this if you're interested in playing around with it. Unfortunately, it's not this GUI. It's a little bit harder to use, but it does work. So again, we probably won't cover this in this class. We do have a video on it if you're interested in playing around with it more. Any questions about any of these projects? Cool. So the slides will be up in just like once class is over. So if you want to dig around and look at stuff a little bit more in more detail, we've also linked to things if you want to like just sort of dig around and check out those links as well. Wait, is this, oh, this is actually me still, isn't it, Leah? Sorry. Long day, long day. All right. Cool. Okay, so we're going to talk a little bit about Runway. I know many of you in this class have already either taken a Runway class with me or have used Runway before. So I won't dig in too much into how Runway works. We do have a demo video if you're interested in sort of just like doing it yourself. But I think it's helpful to talk a little about how Runway trains stuff to maybe then also figure out how we can train stuff on our own server. So how does Runway train? So training in Runway, if you've not used Runway, Runway is sort of like a GUI for machine learning models, sort of like described as the Photoshop of machine learning art. It's a pretty cool tool. I definitely recommend checking it out if you haven't played with it yet. You can train, I believe, 3 different models. There is a StyleGAN model, there is a a text training model, and there is a object detection training model. So there's only 3 training options, but there is a StyleGAN training option in there. So basically you upload your data set to them and it trains things. Some notes about training in Runway is it feels kind of fast. I don't know if it actually is fast. I'll talk a little bit more about that in a minute, but yes, it feels fast. It is trainable. It feels okay price-wise. Like the nice thing is it's a GUI, so you don't have to do any like line coding or anything like that. But it has some drawbacks in that it is like it's on a Runway system, it's on their system, it's on their servers, so you do have to download stuff. The more I think about it, the more I think the price is probably a little bit overpriced for what we do, or like how we're going to train in our classes. But it's a good thing to play around with if you're just interested in seeing how it works. So this is the interface for it. If you've not seen it before, here are all your data sets. You can upload your own data set, and then you can run it through the training system. It's pretty straightforward. There is a video somewhere in here that I've added to it. The costs for it it's not cheap. To be honest, it's not cheap. First off, you have to have one of their plans, which is $15 a month. You can cancel it at any time, so if you just want to play with it for a month, you can do that. Once you have a plan, which is $15 a month, you can then train on top of that. And training is going to cost you ½ cent per step. We'll talk in the next slide about what a step is. But a step is essentially, as I talked about, that training step of like, you check to see if the images are real or fake, and then you update the weights. A step is the updating of weights. So there's a little bit that goes into that. The creator plan does come with bonus credits, so it's sort of like MTA, where if you like give it $20, you get like $5 back or something. So if you're going to play around a lot, or if you're just really interested in playing around but not having your own server set up, Runway's worth it. I think it's worth playing around with. There's something like 60 models or whatever in there, so a lot of models that I don't cover in my classes are there that you can play with. So it's interesting. It's worth exploring at least. So the biggest problem with training in Runway is that we don't really know what any of Runway's settings are. So literally today, someone showed the ADA model to them, and one of their founders responded and said, yeah, we're already doing something sort of like that in our own training. I was like, oh, I didn't realize that. It makes sense. I mean, it's basically they have their own black box version of StyleGAN that they're constantly modifying. So like questions of like, does it use mirroring? Does it flip stuff left and right? At one time I thought the answer was yes, but now I don't think it does. Maybe they changed it. So like they also don't tell you when like stuff updates or like that sort of thing. So it's really hard to figure out what's going on in there. I don't know any of the training parameters. I've asked them a couple times, and I usually get like vague responses that like tell me a little bit more, but like don't tell me exactly what's going on. So it can be just hard to figure out what's going on there. It can be hard to like, if you don't like your version, like how do you fix it? How do you make it better? So that's one of the challenges in working in Runway. So there's this concept of steps, and we'll talk about this more next week, but StyleGAN has a concept of K images, which is a different thing entirely. And I think a step converts to this. And so I think one step equals 32 images, which I believe is the batch size. It's like the default batch size in Runway, or sorry, in StyleGAN2. I think they might have just kept that. It could be 16 images, in which case this gets even lower. So like, I sort of don't know. Here's what I imagine is sort of happening is 3,000 steps equals 96,000 images, which would equal 2.5 ticks. This might not make any sense to you, but it will make sense to you more next week, I promise. All that to say is this is not a lot. 2.5 ticks is, so that StyleGAN2-ADA, those flowers I showed you, that has been training for 3 days, 2 days is 600 ticks. So that is far, far more ticks than what are here. So, and if you've done anything in Runway, you know that 3,000 steps is where they recommend you start, and that is a very small amount. I recommend you train between 5,000 and 10,000, which is 4 to 8 ticks, and that is $25 to $50. So that is pretty expensive for a very little amount of training time. Once I did the math, I was like, maybe this isn't worth it. I used to say that this is worth it, and now I'm sort of questioning that. So yeah, so I usually recommend that you train for 1,000 K images minimum. And we'll talk about that more next week. Or sorry, yes, 1,000, yes, the 1,000 K images minimum. So that would equal to 31,250 steps in Runway and a cost of $160. That price is probably high, but it kind of depends on your server. I mean, again, it's Runway. They have like a GUI that's a system. They're trying to make money off this. They're probably paying similar or less server rates on like a bulk discount than you are. So it's, again, they're charging you an overhead that is very real. So think one other thing I think that's going on in Runway, I honestly think that they do produce very good results for that very short period of training time. I'm like surprised that they look as good as they do. I think they've done some other things that we'll talk about this more next week, but have done some things to reduce what are called mode collapses or other problems. I have some ideas on what they're changing, but again, I don't know exactly what those values are. So the truth is, I don't really know what's going on in Runway, but I know it produces like fairly good results for the time you train for, and you're paying for it, so it's like helpful that it's like good. But in so basically the long-term question is like, should you be training in Runway? If money is really important to you, which, we're going through a global downturn and a global pandemic and money is like tight for everyone. If money is really important to you right now, I would say, no, don't do it. What we're going to do in the class going forward is going to be much, much better. So I don't think you need to worry about that. But one thing I do think is valuable is if you have a little bit of money and you just want to play with this, try doing a training in Runway and then compare it to what your training looks like on a server. One, we might just learn something about like, oh, actually these sort of images do better on Runway and these do worse on a server. But it might also just help you understand like, okay, I really hate writing command line code. Like, is it actually just better for me to spend the money and use Runway? Like, are the results close enough that it's good? So I think, again, doing comparisons is helpful just for you. I will always try to like reduce the amount of money you have to spend because this is a very expensive field to be playing in. So I will always go for like the cheapest option just to let you know. But I also think if you've got a little bit of money to spend and you just want to experiment and see what happens, I think Runway is a very valuable thing to look at and at least explore and experiment with. So it's worth trying, but that's sort of my caveat is like, it's really not worth the money if you really like are tight on that. Okay, here's the training demo video. I'll also add, I have a lecture. I think it's actually from the class that I taught with Michael. So there's also a recent lecture where I like talk about a lot of these details and other things. So there's a demo here if you're interested in it. There is a lecture here if you're interested in it. Feel free to watch either of those and see if it makes sense to you. These are the steps. I won't go into them in detail because they are covered in that demo video. But again, because it's a GUI, it is fairly nice. It is fairly easy. It is a much easier process than having to upload this to your own server, which we will go through next week. If you do the Runway demo, I think it's worth doing it just to sort of see how easy it is. Because then when you do it on a server and you realize how much it sucks, you kind of understand why it's worth paying Runway some money. So, just understanding that is helpful, I think. If you don't yet have a Runway account, I know some of you have taken my Runway classes. If you don't yet have a Runway account and you want to set one up, let me know. Usually I can get you like a 3,000 step training for free as like a demo. I know the Runway folks pretty well, and they might be mad at me for saying Runway isn't good for training anymore. But yeah, I'm happy to like sort of say like, hey, I have a new student, can you hook them up? So if you haven't done this yet and you are interested, let me know. It usually takes me a couple days to just talk to them and have you get assigned like a testing account. But do set up an email, like an account with them, and then send me an email with what your email address is, and I can get you access to that. You also get $10 in free credits when you sign up for it. Those don't really apply to training because you also have to have a creator plan, but you can at least sort of like play around in the interface as well. So Runway is definitely cool. Like I actually use it quite a lot when I'm doing some like really quick testing of things because it's just easier than setting up a server or like throwing up a Colab notebook. I do use it fairly often in my own practice, but it's not for everybody and it is fairly expensive, just all things considered. Or like after paying for this class, you should be able to do everything that you don't need to do in Runway, basically. Save yourself some money that way. Any questions? Okay, last thing we're going to talk about is your homework for the week is to get basically a basic setup on a server. Now, this is a very, very complicated topic because all of us have different knowledges of technical skills. All of us have our own level of like comfort with certain tools. So I'm going to try to break this down as best I can. But there are many, many options for this. These are just a couple of them and probably the ones I would recommend looking at. So first off, why do we have to do this? We need a GPU. We need a very powerful GPU to run this training. Most of us do not have that powerful of a GPU on our computers. And even if we do, like let's say we have an 11 gigabyte card that we use for gaming, when you run this, you will basically lock up that card. Like you will fill up that card and you won't be able to use your computer. So like most of us have a gaming machine because we want to game like, throughout the week. If you train on this, you'll basically like not be able to do any of that. So usually what a lot of folks do is they will rent a server. There are many options for this, and we'll go through all of them, but you'll rent a server just to be able to do that work for a little while. My general rule of thumb is if you are like, and I've done the math here, and you can probably do the math yourself. If you are using this for like steadily for like 6 months to a year, it might be time to build and buy your own machine. But like if you're just using it sporadically, like, you know, maybe once a month or whatever, you should not be paying for a machine because they're very expensive. These cards usually go for about $3,000 retail or higher, and that's not even including the rest of the machine. So like if you want to build your own machine, you're looking at maybe $4,000 to $5,000 to build your own. The price of these is much lower than that. So again, it's just sort of like, at what point are you using this thing so much that you want to build your own machine versus just using renting tools from other places. So your options are Google Colab, which I'll talk about a little bit. That is probably my recommendation for most folks, and I'll talk about why in just a minute. Google Cloud Platform, AWS, Google GCP and AWS are pretty similar. And if you were asked like which one would you choose, I would choose GCP because it's a little bit cheaper. But some of you might be technical enough that you've already used AWS and you can just like go ahead and do it. Both these interfaces really suck, so just be aware of that. Paperspace is the option I usually go through with my classes when I was doing a lot more of this as a class setting. And lastly, Vast. So I'll cover each of these in more detail, but just know that you've got a lot of options. All right, so Colab. So Colab is Python notebooks that run on Google servers. It is a website. It is a URL-based website that is run and managed by Google. The price for this, which is, again, I will always go for the cheapest price for you, is free or $10 a month for Colab Pro. Now, Colab Pro is technically only available in the US and Canada. I have heard from folks that there are ways to get around that. If you have a credit card that works in like US retail or whatever, you might be able to get around it. As far as I understand, they kind of check, but they kind of don't. But Colab Pro, if you can afford Colab Pro, hands down, that is my recommendation for you, especially for this class. Colab Pro gives you longer training times. We'll talk about what that means in a minute. You basically, with Colab Pro, you'll get about 19 hours. With Colab, the regular version, you get about 8 hours. And you have a higher likelihood of getting a better machine. So this is also a very complicated topic, but a V100 is probably the best machine you can get today. And you can get those through Colab Pro. Like they just started offering them about a month ago. It is a very fast machine. It's very, very good. You can sneakily, I don't know if this is like well documented, but you can run, at least for me in Pro, you can run up to 3 notebooks at once. So you could technically run 3 StyleGAN trainings all at once. You'll have a lot of browser tabs open, but you can do it. The downside of Colab is that you must restart your notebook every time your machine restarts. So basically, if you are on Pro, that means every 19 hours you have to restart your notebook. And if you are not on Pro, it means every like 9 hours you need to do it. So remember that training might take about a week. So you will be restarting your training process every 20 hours for a week. That is not fun, but it's also not terrible. It's like, takes 5 to 10 minutes to do it, and it's doable. So basically, this is like the best price you can get for a little bit of annoyance. Like quite literally, if you spend 8 hours a month, you will get your money back in Colab Pro. So like you do a 1/10 of a training and you're paying for it's paying for itself. So this is my recommendation for folks if you are okay with a little bit of manual labor and you just really want the best cost-effective thing and you happen to be able to get around their Colab Pro settings or whatever, this is what I would recommend. Hands down, it's the best. There's lots of stuff you can do with it. Lee and I just finished up teaching a class on Colab 2 months ago. So we have a lot of resources if you're interested in learning more, but I would definitely recommend checking it out if you can. The previous class that we did for StyleGAN2, we set up everyone on GCP, and it was okay. I won't say it was the best experience, but I think it was fine. GCP is basically Google's version of AWS. It gives you a bunch of Google setup servers. You'll see here that a V100 on Google costs $2.50 an hour. So that's sort of how I'm doing the math of like if you spend 8 hours here, which also can give you a V100 through Colab Pro, you will make up your money very, very quickly. $250 an hour is pretty pricey. They do have some cheaper ones available. There's a P100 available as well. And also I'll say that if this is the first time you're using GCP, they give you $100 in free credits to start. So that kind of makes up for it. So $100, I don't know what the math is here, but that's a couple days of training time. So, you know, there's a little bit of there's a balance there. The Basically, the trade-off between a V100 and a P100 is like training time. A V100 will be like 1.5 times as fast or faster than a P100, but I think at like 2.5 times the price. So a P100 is probably good enough, and it's sort of the value-based version. So again, sort of like think about it. If GCP is what you want to do, this is the way to do it. The nice thing about GCP is it can support multi-GPU training. So if speed is an issue for you, you want to train stuff fast, you can, I believe, get 2 or 4 V100s at once. Although I think we actually ran into issues with this previously with like personal accounts. I think you can get a 2x V100, which means it will train twice as fast on a V100, but it's very expensive. It's like $5 or $6. So just beware, like, again, balance out money versus time and those sort of things. I'll say GCP is like kind of a pain in the ass to use. We have some videos set up on if you're interested in this, but I generally say if you're not a technical person, if you have not set up servers before, GCP is probably not the best solution for you. Likewise, AWS. AWS is the most popular server system in the world. It is also, I'll just say it, it's the most expensive. I've never seen prices that are, well, I've seen people that build on top of AWS and charge more than AWS, but like, I am not recommending any of those, so like don't use those. But AWS is definitely gonna be the most expensive. If you've never used AWS, like just don't use this. It's fine. Just like don't worry about it. Some of you I know might have used the AWS, and maybe you prefer like that sort of setup. You can do it. Also, I have to be honest, the pricing on AWS like makes no sense to me. But I've tried to like decipher it like many times. It's really set up for like corporations who like, you know, just they're just ready to check and they're like, whatever, I don't care. For you and I who might be trying to like penny pinch, like it doesn't make any sense to me. So maybe avoid AWS unless you're really like tied to it. Paperspace. So Paperspace is going to be my recommendation for folks who are not like server people, but they don't, either they can't get Colab Pro or they just want to do something that's a little bit more GUI friendly. So I just finished up a video on installing this whole thing on Paperspace. It took me about 20 minutes. So it's fairly straightforward. It's pretty easy. The pricing is decent. I don't think it's terrible. So you can get a P5000, which is basically a P100. There's all sorts of reasons why they name these things weird. So P5000 will be 78 cents an hour. That's a pretty decent price. I've yet to find a better price through one of these systems. It is slower than a V100, but it's not 1/3 slower. So it's like, for the price, again, it's good. One thing that you have to know about Paperspace is you have to request a P5000. I cover that in this demo video, so if you're interested in it, just watch that. But everyone that I know that has said Paperspace sucks, then goes to GCP and is like, oh, actually Paperspace is great. So they go back to Paperspace. Just more friendly folks. They're right up in Brooklyn, or they were before we all had the pandemic. I know them fairly well. I have a referral code, which might get you like $10 in free credits or something. It gets me free credits, so like I hope it will get you stuff too. If you want to sign up for that, like just use this referral code, and it's probably the best way to get set up. Where's my video? Oh, here's the video. So here's a video on actually doing, this should be not Paperspace training, it should be getting it set up on installed on Paperspace. So that would be my recommendation for folks who are interested in server stuff and don't want to spend a lot of time dealing with settings and things. My last option is a thing called Vast.ai. You literally rent a stranger's GPU. Like they have a server, like they have a GPU connected, and you can rent theirs. That sounds really weird, and it is very weird. But what I like about this is the pricing is way more affordable. So if you are like a little bit more comfortable in either writing bash scripts or setting up a server, Vast is like very affordable. So I might recommend Vast for people who have a little bit of server knowledge, but it's because it's super affordable. You can get like really good GPUs for like pennies on the cost of GCP. Like I think I see V100s up there for like 50 cents an hour. Very nice. The challenge is that it's not as reliable. And there's a bunch of scoring. They score all the various servers and reliability and T-flops and other things. So you do have to do a lot of backups. You do have to be like aware that your machine might go down. There was called a preemptible GPU, which means, or I guess they have preemptible and non-preemptible. But basically like someone, again, some random person owns this GPU, and if you've been training on it for too long and they want to use it themselves, they might just like turn off their machine, reboot it, and you get kicked off. So again, you have to really think about like reliable and frequent backups, which again, I don't want to make this class too much about like server usage or that sort of thing, but just be aware of that. So there's a lot of challenges there. So TLDR, like I think Colab Pro is the best if you can get away with it. It is a little time consuming, it's a little annoying, but it's definitely like bang for the buck, like hands down the best option. And I have a video that goes through like how to basically set everything up to work on, basically what you do is, I guess this should also be something I mentioned. As a part of Colab, you should also have a pretty big Drive account. So a Google Drive account of like 1 terabyte or 2 terabytes, because basically what you're gonna do is you're gonna use Google Drive as your disk space, and you're going to use Colab as your interface. And what it'll do is it'll save all your files directly to Drive, so that when you get disconnected, everything's already saved in a Drive. And then you just restart it, you reconnect to Drive, and you kick it off again. So it takes 5 to 10 minutes to do that. So you do need also like, I think 1 terabyte is like 100 USD for a year through Google. So again, the prices sort of balance out in the end. But I would say Colab Pro is still my recommendation if you can. If you want a set it, forget it approach, but you're not really a server person, Paperspace is probably my next recommendation. And if you're a server person, just do whatever you want to do. Like, you know, my hope is that like if you're into issues, you'll be able to solve them yourself. I'm happy to try to help where I can. But it's kind of DIY. You're kind of on your own if you go outside of Paperspace and Colab, just because it can take me a lot of time to get set up and like test things on your end. So just be aware of that. This is TLDR, which I just covered. Basically, you're kind of on your own if you're outside of Paperspace or Colab, but I'm happy to try to troubleshoot where I can. But if we get too far stuck, I might just like shrug and kind of be like, I don't know. Paperspace training video is here. I know we're getting close to the end of time, so if you have to drop off, got like 2 minutes left. For this class, we're gonna use a forked version of the brand new StyleGAN-ADA repo. The repo, like I said, literally came out Friday morning. I have started adding some features that I know we're going to need into it from previous community forks. The crazy thing about StyleGAN is there's just a big community of people using it, and there's people doing all sorts of weird different things within it. So actually, before this repo was released Friday, I had an idea to teach a different repo that had a lot of similar techniques, but was not officially an NVIDIA fork or not an official video repo. Once the new one came out, I played with it for a day and I was like, yeah, we got to do this for a couple reasons that I'll talk about more next week. But just know that like I'll be making a lot of changes to this. I also, fingers crossed, might break things. So like if you at some point like are like, this isn't working for me, just DM me really quickly and it might be that I broke something. So I'll be doing lots of fast edits to this. Fingers crossed it works fine. I know the training works well. So we should at least be able to start training next week with things. But yeah, just know that like it's probably gonna be moving pretty fast. So I'll recommend that you always do a git pull every time you open up the server and get started. I'll cover some of that more next week. The steps to installing, so again, if you're gonna do Colab or Paperspace, you actually don't need to do the Anaconda environment. It just turns out that their settings are just fine for what they have. If you are gonna go into servers, I do recommend you use Anaconda or some environment management package. If you know what that means, then we're good. If you don't know what that means, then I definitely still recommend Paperspace or Colab. And then you're just gonna clone in the repo. For folks who are going to use Colab, if you just want to let me know, I'm working on a notebook now and I can share it with you and make sure that it's set up right. For folks who want to use Paperspace, their video that I covered on how to set up Paperspace already includes all this stuff. So if you go through that step, you should be good. And then lastly, I just recommend running a test example. I give a test example in that Paperspace demo of just like running one of their default scripts to make sure it runs correctly. The challenge with this, if you're going to run on a non-Paperspace or Colab server, is that you have to have the exact right version of TensorFlow, the exact right version of CUDA. It can turn into a nightmare. So yeah, so I just recommend like there is a video that we did in April or May on setting stuff up on GCP, which I'll link to. Actually was linked to in Leah's email to everyone. If you follow those steps for the Anaconda environment, the new repo will still work with that as well. So basically like just do through the Anaconda setup, and then you'll just clone over the repo. And so I probably have described already why you can't train on your computer. If you do happen to have a computer, it's basically the same process. I would recommend installing Anaconda and then creating an Anaconda environment that is just for StyleGAN2, cloning the repo, and then running a test on it. If you have questions about that, I'm happy to talk through those and I can send you some links to things. But I would imagine, I mean, also worth knowing is like, if you're going to train on your own Linux box, like I can't really help, like, unless you want me to SSH into it or something. So you might be on your own. So just again, like, how far in do you want to be on your own versus how much do you want to have me or Leah help you? Just be aware of that. Okay, one last thing is I know everyone has a data set, so I think we're probably good here. But in case you don't, just make sure that you have a data set for next week, as we will be doing some training. Leah and I linked to a bunch of data set playlists if you're interested. Another note for this is in the StyleGAN2 class we taught in April, we taught how to train non-square images. I've sort of backtracked on whether or not you should do that. And my current thinking is that you should not be training non-square materials, even though you can. I would recommend not doing it. The reason for that is that a lot of these other tools like GAN Space or other things are only set up to work with square images. So if you don't do those, then those things break for you and it can be kind of frustrating. So what I would say is if you have a non-square data set, like say you have things that are all 4x5, what you actually do is you stretch it to be a square. So what you do is you train it on a square, and then when you output it, you shrink it back down. So like basically that works. I swear to God it works. It sounds weird, but it actually works. And that's sort of the technique that I've been using most recently is, take your data set. Your data set should still all be the same proportions. So you don't want to mix like 4x5 and 1x2 because that will get weird. But if all your data set is like all 4x5 and you stretch it to 5x5 or square, and then you train on that, and then you generate images and you just squish them back down, it works pretty well. So that's sort of my current thinking. If you really want to do non-square data sets, or for whatever reason you have something you think might do that, I'm happy to link you to some resources to do that. Just know that some of these other like sort of community-based tools might break. And that can be, basically I just want you to know about that ahead of time. Okay, of course we went 10 minutes over, I apologize. So assignments for this class, like by next week, please have a server or Colab set up. That can be as simple, if you're on Colab Pro, that can be as simple as just like signing into Colab, finding the Colab Pro button and paying for it. Lee and I are happy to walk you through that if you want to during one of our co-working sessions, but please try to have one of these set up. So if you run into issues or you just want someone's help, please try to come by one of the co-working sessions before next week so we can set you up with that. Lee and I are happy to like walk people through that. Again, I would say if you are not comfortable doing this, like you definitely should be using Paperspace or Colab Pro. Pick a data set. If you don't have a data set and you don't think you're going to come up with one by next week, let Leah or I know. We're happy to share some of ours with you. That is probably the key thing, is that you have a server and a data set next week. We'll be walking through the steps on how to do your first training. Cool. So with that, that's the end of class. Please post in Slack if you have questions about anything. If there's any issues getting set up, please DM Leah or I, we're happy to talk through things. And then one last thing is, like, maybe before you go to bed tonight, please do fill out this poll. We will be offering co-working sessions starting like this week. And hopefully if everyone can have an answer in by tomorrow, we can actually set those up this week and then get people involved. And I know last time we had some issues with like folks in Europe, so Matt was kind of like left in the lurch. Promise that won't happen this time. So if there are, like, I would say if you are not in the US or not on our time zones, please just DM me and let me know what times do work for you, and we can make sure that we work within that. So I know Matt and I have talked a little bit about what times work for him, but I know there's some other folks here who are also in other time zones, so please let me know what works for you guys. Cool. So with that, class is over. So if it's late for you and you want to take off, go for it. Yes, Matt, bye. For the rest of you, if there are questions or things that I can walk you through, like, please, let's spend like the next 5 to 10 minutes just answering questions for folks.
Who was the AK guy on Twitter you said to follow?
Oh, it's in that slide deck. It's like AK9.
I have it open.
Okay.
It's AK9251. I'll also just send it to the chat.
Yeah, thanks. Yeah, I think I've discovered that I want to say they, because I just don't know if it's he or she, that they are like a grad student in like machine learning at like Georgia Tech or something. And like literally like every post they have is like some cool looking model that I've never seen before. And they will also go through the effort of finding all the GitHub repos for it.
There's a similar guy on YouTube, 2 Minute Papers.
Yeah.
You follow him?
Yeah, 2 Minute Papers. The thing I don't like about 2 Minute Papers is like, they don't ever show you how to actually use them. They just like talk about how cool it is. AK does a great job of actually, here's the GitHub link for it. There's another person, Yannick Kilner, I think, there's also someone on YouTube, and they actually do like more like explanations. Like they're like 20-minute long videos into each paper. I'll link to those as well. There's also, there's another one I'm blanking on. It's like Blue Dog Studios or something. I forget the name of it. I'll find it. They're also very good. A lot of people are good at explaining the papers or like good at like sort of talking about the papers, but they don't show you how to do any of the code. So it's like cool. And then you go to the repo and there's like no documentation and you're like, oh, this sucks. Like, I don't know what to do with this. So I guess that's why I'm here.
For something like that wave video that you showed in the inspiration section, so that person literally just took frames of like one or a couple, videos of like waves, and that's all it produces, right? Like that model would only essentially have waves, and it's just like stitching it together. Yeah,
so I did that one. I literally went to YouTube, typed in waves, downloaded a video from it, and split it up into frames, and then fed it through Runway. I should do that with I should do that exact same data set in a newer version and see how different it is. But yes, I also have one that I think I posted before that's like a nuclear bomb from like a 1940s like test site video. And again, it just sort of repeats what it already shows, but it has like weird skips and weird places where it like moves into a new region. It's cool, but it like is kind of a one-shot pony in that it's like, you're not going to get anything too surprising. It's just more like an interesting way to like reanimate a video you already have.
So Kishiyuma kind of does something similar for like the hand one, I assume, right?
Yeah.
Mm-hmm. Yeah, I think he also has one work that I think he trained a StyleGAN on a video of like or I think it was a mixed data set of like a woman rotating, but then also I think the other half of the data set was a flower bouquet rotating.
Flowers, yes.
So
yeah, that one's beautiful.
And so like it's like the model learned like the rotation of the human, but then it also at times it like morphs into flower rotating as well. And that one's really cool.
Do you know a quick way just to take out images of a video at a certain rate? Or do you have any suggestions on that? I'm lazy.
I have a video on that. And there's also like a one-line script in FFmpeg. I'm just going to make a note for Lee and I to find that video. Yes, there is like a one-line FFmpeg code where you just basically give it the input and then you say how many frames per second you want. You get an output and it generates all those frames. Yep. So a common thing that I do with those, and God, I should really just record a video of this, but basically like do an output at like 3 frames per second or whatever, and then the dataset tools library that I have also has a deduping script, which will literally like match up frame to frame and see if there's duplicates. And that's a nice way to just make sure that all of the frames you have are singles. And there's also a way to sort of do it where it's like, there's absolute, which is like every pixel is the exact same, and there's like a relative, which is like a little bit of fuzzy version, which is like, we'll do some fuzzy matching. I think I have a video on that as well, that I will post as well. But those are my 2 techniques. So I sort of like take the video, I then dedupe all the frames, and then again, I'll usually squish it into a square, which that is something I do need to record, is how to actually do that using the datasets tools. So there's one thing you can just crop in, you can just crop it, or you could squish them. So for a video, if it's 1920 by 1080, you might want to squish it down. But one thing to know about that squishing technique is then the longest side that you want is only going to be 1024. So if you take a 1920 video and you squish it down, it will now just be 1024 by like 600 when you unsquish it, right? Because otherwise it'll get blurry or pixelated. Then you have to use another machine learning model to actually like up-res it, other things. Like it gets kind of complicated, but just know that that is sort of one of the downsides of these things. Other questions for people?
Are the slides up? Didn't
Probably not. I think I probably like haven't put them up, but they'll go up in like the next 15 minutes or so. And then yeah, the video will be done. Video is usually like processes in about an hour, and then I have to upload it to YouTube, so it takes another hour. So usually by the end of the night, videos are up. All right. If that's it, I will see so Leah and I will go through the poll results. So hopefully everyone can respond by sometime tomorrow. We'll go through and we'll schedule a co-working sessions and we'll announce this as soon as we can in the Slack channel. I will say co-working sessions are really great. It's sometimes cool just to like come in and hear what other people are talking about. It's really like a nice sort of experience, like hearing what other people's problems are, and maybe you have a solution, or maybe you don't, or you just want to hang out and sort of learn by osmosis. So if you can attend those sessions, I definitely recommend them. All right, cool. More Slack notes to be posted in the Slack channel tonight, but we will see everyone next week at the latest. Okay, cool. All right, bye everybody.
Bye, everybody.